because surface charge, which will cause the repulsion between the particles, makes the particles apart and keeps the colloidal dispersion stable. There is another thing what we have already discussed previously is we need to provide the particle around it the protective solvent sheet that prevents the mutual adherence when they are colliding with each other in case of Brownian motion. If we don't provide this particular sheet, the barrier effect will not be there. Then they tend to adhere with each other and they tend to precipitate from sol to dispersion state. This is most preferably present in the case of Lyophillic solutions, that is colloids. They are existing as solutions in the colloidal state only, but they will be converting into particles by this mechanism when you are removing the solvent sheath by the dehydrating effect. This is immaterial of the charge. So there are 2 points which you need to remember. It will make you confused in the GPAT. They will tend to give 2-3 clauses and make you confused, because one way it is saying that surface charge is important and accordingly we can make the stabilization, and another second point it says that the immaterial of the surface charge, if you deplete the solvent by the dehydrating it, it will be having a action immaterial of the charge. So both are opponent phenomena which are going to act, but the second phenomena is predominant in the lyophilic solutions and the first phenomena is predominant in lyophobic colloids. This is what you need to call the association nitrophilic, that is lyophilic and the lyophobic colloids. You have got lyophobic colloids are thermodynamically unstable. So this is the reason we need to consider their stability with a due care, so that we will be able to make them stable for the shelf life of long years. So we all know that generally we are giving these drugs in the angstrom, that is the international units, very microgram quantities only. So they will be appearing as a sol form only, not in the colloidal form when you are giving these protein dispersions. Most of the times the stability will be getting affected by the alterations of the surface charge. So the surface charge alteration can be from the packaging. That is the reason we are studying the compatibility with the package with your dosage form, what you are going to study, and the pH effect, and you have got a complexation and the metal ion effects. So these are all phenomena which will change and alter. So the like charges which produce the repulsion, that is the reason we tend to create a surface charge enhanced beyond 30 millivolts to improve the stability of lyophobic colloids. Because it prevents the coagulation. Reason is that the surface charge which are having a repulsive forces. So what we need to do, we need to add a addition of a small amount of electrolyte. Here what electrolyte we need to add the same charge. So we are increasing the surface charge by adding the similar charged species to a lyophobic colloid, tend to stabilize the system by imparting the charge to the particles. So whenever you are going to add, which potential is going to be getting affected first? Can anybody answer? Whenever you are adding electrolytes, which potential is going to be getting affected by adding a electrical charged electrolytes? So which potential is going to get affected first?
Zeta potential.
Can anybody answer? Exactly. So zeta potential, Mahima, you are correct. Because it is second layer, it is having, if you are able to observe this bilayer concept in the electrical theory, and if you are seeing the effect of DLVO, that is the distance of two particles, another one is the solvent sheet effect. Around the 3 points, all the things will be moving. So whenever you are having a DLVO theory, there it is having one thing is a charge, whether it is a repulsion or attraction, and distance between the two particles. Whenever you are going a surface ionization, you are having a zeta potential is the major phenomena. The third one is a solvent effect, solvent sheet, but it is predominant in the lyophilic only, not in the lyophobic. So all the three which will be having a compromisingly, we need to see it. That is the reason whenever you have got a nernst potential, it is higher than the zeta potential. We need not target to nernst potential at the Stern layer. We need to target zeta potential at the diffusion layer, because that layer only getting exposed to the surface of your particle when it is moving, not the exact particle around it. It is containing some diffusion layer. So this is what we need to have a GPAT concept of a question you are answering it. Generally, we tend to see that the surface charge which is present on the particle, which is higher in the Nernst potential, we need not neutralize or enhance by taking the potential into the account. So we need to consider in our formulation development only zeta potential for our success of stabilization. So this is what we need to do. In the colloidal dispersions, frequent encounters between the particles occur as a result of the Brownian movement, and such interactions may be responsible for the two types of interaction. One is attraction and the one is the repulsion, and we are calling synonyms. The attraction force is called also called as van der Waals attraction, and the repulsive force is also named as electrostatic repulsion. So when these attractions are predominant, it will form agglomerate. When the repulsions are predominant, it will have a stability. So the particle adhere to the collisions, and they will form the aggregate when the attractions are the predominant. By adding electrolyte, the repulsions will be predominant, and the particles and they will go back to their original position of movement after collisions also remain individually dispersed. Now it is taking that what the effect of our electrolyte onto the zeta potential, that is depending upon the concentration of the electrolyte which are adding to collapse the repulsive forces to permit the coagulation, depends on the valency of the ions we have already seen. That is the reason we need to consider this valency of the ions which are present in the formulation. By we are adding, it may be for the tonicity adjustment or pH adjustment, or we are going to have a buffering effect, or it may be sometimes it will be a preservative or anything. So in those particular case, we need to see that Hardy-Schulze rule we have already stated that it states that precipitation power of the ion is opposite ion of the dispersive phase of opposite charge increases with the increase in the valence of ion. That is one point. The second is charge of ion. I have already informed in the previous class. You do remember that in GPAT you will be getting confused and write a destructive answer, even though your valency of certain ions are trivalent or divalent or monovalent. So monovalent, there will not be any confusion. So monovalent ion will be existing as ionic form or non-ionic form. So in the non-ionic form there will not be any charge. In the ionic form it will be having a +1 charge or -1 charge. So one monovalent, one charge species will be present. But in the divalent, trivalent, they will make you confused in the GPAT. If you are neutralizing one of the valency with the addition of some opposite acid or base, then that neutralization causes the reduction in the surface charge. So even though the trivalent ion may act as a divalent or monovalent depending upon its surface charge which is present on the trivalent ion. So this is what you need to see. We know that in our laboratory you see phosphate ion will be existing in form of trisodium phosphate, disodium hydrogen phosphate, sodium dihydrogen phosphate. All the three are existing. So this is actually what the extent you are neutralizing it depending upon the surface charge is present. The higher the valency of the ion, the greater the precipitating power. We have already seen according to the Hardy-Schulze rule, and this is very important for the neutralization of zeta potential. So this is indicating that trivalent aluminum is more precipitating power than barium and calcium than sodium, and in the case of anion, phosphates are more than sulfates than your chlorides. So this is already we know it. But in the stability of your suspension, that is colloids, with respect to solvent sheet, immaterial of the charge, we are going to have a depletion of the water by the dehydrating the surface charge, and we are going to consider Hofmeister series. So this is very much important in the stability of the lyophilic colloids. Till now, whatever we are seeing is lyophobic, and we are considering the charge as a major phenomena, and we are not considering about the solvent sheet. It is a secondary phenomena in the lyophobic do remember these orders. So that will make you confused in GPAT. In regular questions, there will not be much making a difference, but in the multiple choice questions and competitive examinations, this tiny line which we need to remember, that which is more predominant in what parameter, more predominant in what type of colloid. This is you need to answer whenever you are making a decision to pick up one choice from. Generally, what they do, they give A, B, C, D, and they pick up both A and B are correct, and A, B, C are correct, none of the above correct. Like that, they will make you confused in the bottom. So there you will be getting a negative marking generally, because two opponent phenomena may be correct. Sometimes we feel that as it is only one phenomena is predominant, we will do it. So we need to answer critically. So, but in the case of lyophilic colloids, you do remember that solvent sheath effect is more predominant than your surface charge. When it is coming to the lyophilic, when the stability is concerned. Whenever we are calling it is a stability, I have already mentioned that it is a physical stability. That means enhancement of your particle size, particle that is bottom-up approach from the sol to colloidal state. So we are going to have this effect. So in this particular case of lyophilic colloid, your salting effect by the dehydration of the solvent sheath is predominant phenomena when compared to your charge of the species which is present in the electrolyte you are adding it. It means immaterial of the charge when you are adding it, the predominant phenomena which will be taking place in the destabilization of lyophilic colloid is salting out effect. Then after that it will be coming into the existence of your surface charge. The predominant is salting effect. In generally, lyophilic colloids are stable because of the solvent sheath effect around the particle. At a higher electrolyte concentration, ion get dehydrated and water is no more available. It is given as a hydrated, it is dehydrated and no more available for the hydration of the particles. This results in the flocculation and the salting out of the colloidal particle. Here we have got this effect of the excess of electrolyte to remove the solvent sheath. I have already mentioned in your examination, when you are attempting 5 marks question or 10 marks question, do remember that you represent your answer with the diagrams, so that you are going to communicate in a better manner. It will, what I am telling 10 minutes and what is conveyed in 2 pages in your book, what you have got issued, it can be understood and conceptualized and memorized by just understanding the figure. So that is the reason, if you see this figure, the solvent sheath effect is predominant and making the lyophilic colloid stable. But when you are adding excess of electrolyte, immaterial of its charge, whether it is a positive or negative, whether it is same as that of your Nernst potential or opposite that of Nernst potential, anything, when you are adding in excess, then what will happen? It will dehydrate the lyophilic colloid and it will make it unstabilized, because in lieu of your colloid, your electrolyte is getting hydrated, causing the dehydration effect on the lyophilic colloid. This is what you are going to represent in the diagram. And the coagulating power of any ion is directly proportional to the ability of the ions to separate the water molecule. It is not depending upon your charge, because your water molecule is containing both H plus and OH minus. So the dehydration is nothing to do with the charge. Both will have a similar impact. So that is the reason Hofmeister CD has come into the existence. He has given a lyotropic series as a rank. In that rank, even the same valency will have the different lower or higher ranks for the precipitating power. This is what you need to memorize. This type of questions you will be asked in the memory type, and I have already mentioned that you need to solve your old GPAT question paper to memorize such type of questions, and repeatedly you are reading it so that you will be able to answer them. And your intermediate background also can help you to understand, see, make this as an order, because in GPAT they will be asked which is having a among the following monovalent ions which is having the highest precipitating power. The answer is obviously acetate. In the monovalent ion we have got 3 here. It is having a 5. If they are giving a 4 and you are going to have a acetate is the highest power, then chloride, then nitrate, then bromide, and last one is the iodide in this particular series. Whereas in the tartarate and sulfate divalent, you have got a tartar is having a more precipitating power. Obviously, the surface charge that is a trivalent, which is having the highest precipitation power and which is going to have in the highest precipitating power when compared to remaining all. It means its concentration of this which is having, whether it is opposite or the same, which is having a similar effect to dehydrate. Because of that reason, we need to consider cations also. In the cations, magnesium and calcium and barium all are divalent, but magnesium is having a more. Generally, we are using them. In case of barium meal, we are going to have the barium salt, and in the antacids, we are going to have a magnesium and calcium. Generally, that will be having a common component in case of our excipients, because they are highly stable and they will be used without much hindrance, because they are considered as a effective and safe. But when you are using them, the selection of what divalent cation and the material, we need to see this of Mr. series so that we will be able to select a better one to have a better stability. So this is actually what we are learning and applying in the research and development whenever we are making a formulation. In the case of monovalent, and sodium is having a more precipitating than the potassium, and this list will be keep on going, it will be endless. Whenever you are answering the old question paper, you are going to add some more anions and cations which are repeatedly being asked. And even if you read the 100% book of your, whether it is a Martin and whatever you got issued, and you may not be able to answer GPAT, then you may be thinking that, sir, it is not present in my book what I have studied. But in that particular case, you will be able to get those answers when you are referring the past question papers and solving them. This is actually what the attempt you need to do. I hope you are all having some little bit leisure time of half an hour like that. Whenever you are finding it, and just you browse in the Google and let's say that the past GPAT question papers, you click in such a way that along with the answers and solutions. So you will be able to see the question paper and the corresponding answer, you will be able to see it, and you will be come to know that and what is the right answer. It will be segmented in your brain. Whenever you are going to get such a type of question, you will be able to answer. And don't expect that you are going to have repetitions in the GPAT. Entire question papers of 125 questions, you may be having, I think, one maybe a repetition which will be going to come. That is the reason. Don't expect one or more than, not more than two as a repetition of a past question paper. Now you get the question, sir, whenever I'm reading, when it is not getting repeated, what is the fun in reading them again? Because I'm not getting a repeated one or two questions which are having, which is less than 2% like that. But that will help you for answering the conceptualized problems. So that is very much important. Another thing is, you will be putting yourself in the shoes of exam, and you will not get panicked in the real-time exam, because you have answered so many question papers and you have solved them, and the new one what you are seeing appearing as a light to you, and you can answer it. So do make yourself prepared for pharmaceutics, because you have already completed physical pharmaceutics 1 and 2. This you are going to have every time 8 to 10 questions out of 125. 8 to 10 questions generally. I have already mentioned in the colloidal, without having one colloid questions, a dispersion question, no GPAT will be there. The Soft-Mister series, Hardy-Selge rule, whether it is Fick's law or Stokes law, or it may be a Einstein-Stokes law, where so many equations are present. The another one is going to come gold number. So these are all the things which are going to make you confused. So you do remember to answer them now itself by making a small sheet which is handwritten by you. Another one is you need to have a CMB, not the electrolytes, dehydrating effect of the non-aqueous solvents like alcohol, acetone, like that. They want to be present in our formulation because they are safe, and sometimes they will be added as a wetting agents. And wetting agent, we know that the displacement of the air, we need to add some solvent. In that case, we are adding, sometimes we are adding them to solubilize. Sometimes you are adding as a preservative. Alcohol, they are generally acting as a preservative also. So such solvents will also have an impact on the hydrophilic colloids, because they get hydrated by taking the water from the colloid and make the colloid dehydrated and cause the coagulation. So when these solvents are added to the hydrophilic colloids, dehydration of the particle occurs. Now the stability of the particles depending upon the charge they carry. Now you see this sentence statement. Once they are getting dehydrated, the charge will be going to coming as a first picture in the case of lyophilic colloid. So first one is a solvent sheath replace, second one is a charge is going to come. So because it is not having an impact in the first priority as a solvent, whether you are adding a cation or anion, it is immaterial. And you are going to have a dehydration effect. After that, you are going to have a charge, they carry. The addition of even small amount of electrolytes after a sheath is disturbed leads to the flocculation and sorting out of a colloid easily. So this is actually what a critical concept, a hairline gaps between the two concepts will be present. Once you are able to understand all this, and even if you don't read book also, you can answer the GPAT. Some of your seniors, their colleagues, they used to say that he did not read it. I think how could we able to do the GPAT pattern itself wrong? How can he get it? So the score without even going to the coaching center and not reading much, and he has got meager marks in the up to around 60 or 65. He has got cleared the GPAT. It is not that it is by luck it will happen. It is something which you are having a conceptualization, even though you may not be able to represent in pages like others, but the concept it will make the answer correct. Then it will be possible. That is the reason. Be cautious whenever you are learning, especially in the case of organic chemistry, like medicinal chemistry, that is having more impact. And parallelly, you need to go with pharmacology. Pharmacology and medicinal chemistry both will come together hand in hand, and you have got this physical pharmaceutics and your pharmaceutical technology, they will be coming in hand in hand. So you need to link this one whenever you are going, because in the pharmaceutical technology you are going to manufacturing part. There you are going to apply the physical pharmaceutics concept in the NDS and preparation of your novel drug delivery systems, liposomes, neosomes, nanoparticles. So those are all coming. When you are coming to the nanoparticles in the final year, that is the novel drug delivery systems, these all concepts will come there, but you will not be getting taught all these. They will be directly giving the what you are going to consider there, and you are going to proceed with what type of salt you need to add, and you have got all the concepts clear. It means this excipient what we are going to select, it will be giving an impact to our stability dosage form. So we need to choose them critically in the pre-formulation studies. Whenever you are selecting a combination of your excipient for your formulation, this concept will help you in research and development. Another phenomena what we have already seen is co-exacerbation. When the negatively charged and positively charged hydrophilic colloids are mixed together, they separate if they are present individually, because both are hydrophilic, they are present as a stable form, thermodynamically stable form. They exist a stable, thermodynamically stable form separately. But when you are mixing them, you may get the question, why do I want to mix it? It will be happening sometimes. You need to add some binder, or it may be having a coating solution of a multiple polymers. In those cases, you are going an impact of them. This is what you need to answer. So here, you are going to see that when you are getting mixed, they separate from the dispersion, and initially they are present in the sole state, they will be getting separated. So this is what you are generally finding after getting mixed. You are getting a colloidal particle. Previously, it is a solid state. So this colloidal rich layer is known as a coacervate. We don't call it as a precipitate. Precipitate is the one which is very good in the case of your lyophobic systems, and generally coagulate is preferable in the case of hydrophilic systems, that is lyophilic systems. Do remember, one is precipitate, coagulate, and coacervate. So GPAT, again you are going to get confused with the terms. Precipitate is the one which you are having in the lyophobic phenomena very frequent, and in the lyophilic phenomena you have got aggregate or coagulate. But when you are making two lyophilic solvent together, then you are getting a precipitate like, or you are having a aggregate like dispersion, but that is called as a coacervative, because when they are present individually, though they don't have, but when they are getting mixed, they are forming as this. When you are having a oppositely charged hydrophilic colloids, this phenomena in which the macromolecular solutions are separated to two liquid layer is called as a coacervation. So we have already seen the example of gelatin and the acacia. Most of the times isoelectric point is the pH at which the polymer or surfactant is having a least solubility. They will tend to get precipitated. If you want to work on the soluble condition, you need to alter the pH either above or below the isoelectric point. When you are working with gelatin below pH 4.7 or above it, and if you are using in the below pH 4.7, acacia will be having a negatively charged, but they are present individually as a clear solutions. When the solutions of these colloids are mixed in a certain proportion, they coacervate. It means you are adding two solvents or two surface active agents or polymers to get a multiple effect or your effect of required, what you require for the solubility, that is viscosity building or anything. But there you are going to get opposite effect by getting a coacervation. The viscosity of the upper layer now pour in the colloid and it markedly decreased, and lower layer becomes rich in the coacervate, so it causes the problem. Now, whenever you are thinking that hydrophilic colloids are both are present, they are getting coacervating, getting destabilizing each other. That is, they are getting spoiling each other. Now, can we have this hydrophilic colloid for the protective action? This is the last part of your journey of learning a concept, is protective action of hydrophilic colloid. Till now we have seen the stabilization and destabilization. Now we are going to see the protective action by using one colloid to another colloid. Generally, we know that hydrophilic colloids are more stable and hydrophobic, that is the lyophobic colloids, are unstable. When large amount of lyophilic colloids are carrying the opposite charge is added to the lyophobic colloids, so they get absorbed onto the hydrophobic particle, they form a protective layer around it. And now what is the beauty of this particular concept of a protective action is, now onwards the lyophilic colloid, after addition, it will, the lyophobic colloid will behave as a lytrophilic only. I repeat, whenever you are adding a lyophilic colloid to lyophobic colloid, after it is forming a layer, then the lyophobic colloid, it loses its characteristics. It will behave as a lyophilic only. It means the predominant effect in that case is the solvent sheath effect, and electrolyte will not be getting disturbing it as a prime phenomena. So this is actually what we are able to see it, and you are going to have a thermodynamically stable system. So this absorbed layer prevents the precipitating ions reaching the solutions particles. Therefore, coagulation is prevented and the systems become stabilized. So the entire colloid behaves like a hydrophilic colloid, and the colloid that helps to stabilize the other colloid is known as a protective colloid, and the phenomena is called as a protective action of colloid. One colloid is protecting another colloid, and we are calling that colloid as a protective colloid, and the action which is produced by that colloid is a protective action of a colloid. So here we are adding one hydrophilic colloid to hydrophobic colloid in the case of when you are using water to stabilize it. So 5 marks question, generally you are going to get affected. You will be asked, you need to explain with the diagram. In this case, if you see here, either you are, say for example, you have got hydrophobic colloid that is positively charged, and whenever you are adding electrolyte here, what will happen? It will get neutralization of a surface charge. It will be getting a not coacervate. It is not. It is going to get a precipitated, or it is getting a precipitated by adding an opposite charge here by neutralization of your zeta potential. Whenever the zeta potential is reduced, you are getting the coagulation of the particles, and you are going to get separation of them. So you are going to get as a precipitate which is coming down after a particular period of the time when you are adding electrolyte. So you want to prevent this effect. You don't want to have it because you want to add in your hydrophobic colloid later electrolytes also. Then what you do? You add large quantity of hydrophilic colloid. So this is opposite charged hydrophilic colloid you are adding. Then they will be forming as a one layer around them. So that will be producing a protective action. So the extreme right, if you see it, the hydrophobic colloid positively charged, which is having a continuous layer with a hydrophilic colloid, it will be forming as a layer and it is behaving as a hydrophilic colloid, and it will be more stable when compared to original unstable lyophobic colloid. If you are adding any electrolyte to this, you can have the opposite phenomena also. You will be getting a dual, and you are going to have the addition of electrolytes even at the higher concentration. It makes no difference to this because it is having a hydrophilic in nature, so it cannot reach the colloidal particle and no coagulation occur. It will have a protective action. This is actually what you are going to represent in the exam also. You need to understand. And for this purpose, we have got one concept called as a gold number. So the gold number is one which we are going to use as a gold solution to get clarification of our where our protection action is present. I hope if anybody is having a doubt till now, they will be able to unmute. They can unmute and ask me, or we will be going to the concept called as a gold number, and you will be getting repeatedly in the GPAT and 2 marks question. And this protective action will be asked in 5 marks question in the exam. Sometimes you will be asked properties of colloid and protective action of the colloids. Both will be coming. In the properties, you have got a 3, that is electric, kinetic, and optical. And the protective action, you are going to have this, like addition of hydrophilic colloid to hydrophobic colloids to get a protective action. Okay, then we will be proceeding with the gold number. So the protective property is expressed most frequently in terms of the gold number. So what is this gold number and how it is going to help us? And we are going to see the gold number is the definition of the gold number. It is the minimum weight of in mg, that is milligrams, of the protective colloid. That is generally protective colloid is hydrophilic only. That is the dry weight of your dispersion phase. How much you are adding, whether it is 2% or 10%. Generally, you are going to have less than 20% in the colloid and dispersions. So it is maybe around whatever the percentage of dry weight in the dispersion phase required to prevent the color change from the red to violet. Generally, the gold is existing as a sole form in red color. When it is appearing as a colloidal form of a precipitate, it will appear as a violet. It means your solution form of a gold will be changed to the colloidal form of the gold, that is violet. Solution form is red and colloidal form is violet. It means if your sole form is changed to the colloidal form, then you are going to have, there is a change in the system and the stability of your colloid. So we are going to have, how much is it going to prevent the color change from the red to violet in 10 ml of the gold solution on addition of 1 ml of 10% solution of sodium chloride. We are adding the salt to have the precipitating effect, electrolyte effect onto the hydrophobic colloids. So generally what will happen, if you are having this solution added to directly hydrophobic colloid, so you are taking one Lyophillic colloid, you are adding sodium chloride solution to it, obviously the Nernst potential will be getting disturbed because sodium is containing both the anion and cation. The corresponding ion, it will be taking it, it will be getting disturbed and it will form as a colloid. Sol2 is converting it a colloidal form. But when you are adding hydrophilic colloid to gold solution, and even after that you are adding some sodium chloride, it won't change because it is getting protected. It means you are adding some quantity of hydrophilic colloid to make the stability of your gold solution. It will be existing as a solution only. So this is actually what the gold number for some of the protective colloids are given. So they are having as a standard. For the gelatin, gold number is 0.005 to 0.01 mg. What we are going to add for 10 ml of gold solution, this many mg. This mg is present in the colloidal dispersion of what you are adding it. So this is actually gelatin solution. We are adding that much mg is added to have the protection effect. So this much mg, less than that when you are adding it, then it will be converting into the colloidal state by converting from red to violet, because the protective action is not there. And beyond this number, when you are adding it, it will have a protection. That means the gold number is the minimum weight in the milligrams of the protective colloid, minimum weight. That is the dry weight of your dispersed phase. Don't get confused. If you are taking 10 ml, your dispersed phase is containing 1%. It means 1 gram in 100 ml. 10 ml is going to contain 100 mg. So that 100 mg is your gold number. But for the gelatin, the gold number is not 0.005 to 0.11. That much small amount if you are adding to the lyophobic colloid. It means 0.005 grams, which is equivalent to around 5 mg, what you are going to add. That 5 mg is going to, not 5 mg, it is 5 microgram quantities when you are adding it, because it is in the mg. 0.005 mg is equal to, into multiply with 1000, you will get a microgram. So 5 microgram is sufficient to produce a protective action for the 10 ml of gold solution. So this is actually what is going to help you to choose what type of solution or the viscosity building agent I need to select to protect, to have the greater protective action. In these cases, these gelatin and all these, they can enhance the viscosity also, they will have the protective action also. So your shelf life and your expiry date will be drastically improved by having this protective action. I repeat, when you are having this concept known, by adding this, generally you think to, I want to build the viscosity, so that I am adding these solutions, acacia and gelatin, I am going to add it. But not only that, because of this gold number concept, they will be having a protective action, and symbiotic manner you are going to have a multiple effect of the stability you are going to get. One is by the viscosity enhancement, another is by the protective action. This is GPAT question. Whenever you are adding the solvents, so you are going to have a dual role of these polymers. When you are having this acacia gelatin, it will be acting as your system to improve the viscosity also. So that will be preventing the settling, and it will also be enhancing the protective action by having a concept called gold number. So in this particular case, the gelatin gold number is 0.005 to 0.001 mg, which is necessary to have the protection of 10 ml of gold solution. If you don't add this quantity or adding less than this quantity, then what will happen? The gold will be converting into violet color. Red color is converting into violet color. So similarly, you are having a albumin. That gold number is a 0.1. For the acacia, it is 0.1 to 0.2. So depending upon the type of the excipient you are adding it, the gold number will be varied. So, sir, how can I know it? How can I know it? This excipient triacanth is how much is that? You can take this as a product in B Pharma, and you can take all the polymers, and you need to prepare a gold solution, and that is having a 10 ml of solution, and you keep on adding in mg, where your color is seen, and change it to the red to violet. So you are finding that is the minimum quantity which can be suitable for that. That will become one product. So you are giving this data. Generally, the known acacia or gelatin, so many persons have already done it. It is available in the literature. If you are finding a new excipient or new gums which are explored from the forest or the new species, if you are determining it, it is a new work. What you are going to do, it can be adopted in the B-Pharmacy final year project. Most of the times what will happen, these projects, when you are doing it on the new one, it is your invention or your research. You have found out, and you have found the activity as a viscosity building agent and the protective action of that by giving a gold number. So you will have your thesis of your own. So this does not require much equipment, because it is visible. So you are going to have a changing the red to violet color, you can see without using any equipment also. So like this way, you are going to help this concept for your final year project, which you are going to have in the 8th sem. Basically, gold solution is hydrophobic colloid and has a red color. When the electrolyte like a sodium chloride is added, coagulation of the colloid is observed, including that is indicating the violet color. It is already formed. When the protective colloids are added, these stabilize the gold solution and prevent the change to the violet color. And the lower the gold number and greater the protective action. It means when you are adding a small quantity, if you are able to have a protective action, it is excellent. That you are going to have a less quantity or having a more, that means more value, so much power, that is money savings will be there. By adding some excipient, it is going to be reducing its cost. That is actually what you are going to do in the cost reduction projects in your industry. They will be having a cost improvement. The same project will be there, alternative excipient and vendor development. There is separate department will be there. In that you are employing, you are exploring all these activities. It means lower the gold number you are selecting it, you are saving the money by reducing your excipient consumption, and it is going to yield better money returns. So greater the protective action. I hope you understand this concept, and this will be available